This video is going to walk us through an exploration or activity that's going to focus on some of our other trig functions. There are actually 6 different trig functions, and up to this point we've learned and focused on 3 of them: sine, cosine, and tangent. And today we're going to be looking at the sort of 3 partners with those is a good way to think about them. So to start with, let's just learn their names. So one of the functions we're going to be talking about today is known as the cosecant function. And so we abbreviate that as CSC of x. And just like with our sine, cosine, and tangent functions, we would input an angle measure here, and we get out this numerical value. And so I want us to take a little bit here and just look at some cosecant values in relation to sine values. So if you notice here, we have sine of 30 degrees equals 1/2. But if I did cosecant of 30 degrees, it would equal 2. And then I can move over here and notice that sine of 157.38 degrees is negative 5/3, while if I find the cosecant value of that same angle, it's negative 13/5. Hopefully by this point you're noticing a pattern going on here. And then I get thrown for a wrench because sine of 90 and cosecant of 90 is just, they're both 1. That's interesting. But then when I come back over here to 36.87 degrees and I have sine of that value, I get 3/5, and then cosecant of that angle would be 5/3. So if I'm thinking about the relationship between, what I should notice is that sine of x and cosecant of an angle are what we call in math reciprocals of each other. And for those of you who don't remember that term, a reciprocal would be 2 fractions that if I multiplied them, they would be equal to 1. Some people like to think about them as, well, it's the fraction sort of flipped over. But the mathematical definition is that if I took 1/2 and I timesed it by 2, which is the same thing as 2 over 1, that would equal 1. And I could go through and do the same thing for all of these. And so it's like negative 5/13 times negative 13/5 would end up being, the 13s would reduce, the 5s would reduce, and I'd be left with 1, because a negative times a negative is positive. And that's even true with 1 times 1. 1 times 1 is just 1. So the key here is that cosecant is the reciprocal of sine. So one way you could think about this relationship is that if I had cosecant of x, it would be equal to 1 over sine x. That would get me my sort of reciprocal fraction. Now, a second trig function we're going to look at is known as the secant function. And secant we abbreviate SEC with the angle measure. So it's an input of an angle again. I'm going to just make a note of that so we remember. So don't forget, we're still inputting an angle measure here. And we found out, okay, the output was the reciprocal of our sine function. So let's take a look at secant, and this time we're looking at its relationship to cosine. And hopefully maybe you're getting sort of, oh, there's something going on here. There's a relationship. There's a pattern. There's a reason we've grouped these together. So you'll notice cosine of 120 degrees is negative 1/2, while secant of 120 degrees is negative 2. Oh, we have a similar setup here as we did up here at the 30 degrees. And notice, we got the 12/13 and then 13/12, 4/5 and 5/4. And so just like we had up top, what you should notice is that cosine and secant are also reciprocals of each other. So if I multiply their values together, they would be equal to 1. And so just like with cosecant, we can think of secant as simply equivalent to 1 over cosine of x. So it's just the sort of flip-flop version of those fractions. Now, when we were dealing with sine and cosine values on a coordinate plane and within a unit circle, we sort of talked a little bit about these ratios we could create, or these fractions we could create to find the sine value or the cosine value, because remember we were measuring in radius length. So if we took that x coordinate and divided it by the radius length, we would find the cosine value, the number of radius lengths within that horizontal value. Well, if cosecant and secant are reciprocals of sine and cosine respectively, a reciprocal, remember, are fractions that, if I could multiply this fraction by something to equal 1 or sort of flip the fraction, I would get my cosecant of a reciprocal. So instead of y divided by r, if we have r divided by y, we end up with our cosecant value. The same idea with secant. So this time it's r over x would get our secant value. And the table down here is just sort of summarizing that up. Now you'll notice there's actually a third function listed here, and this is known as the cotangent function. Cotangent, guess what? It's also a reciprocal. There's a theme here with our extra additional trig functions. It's going to be the reciprocal of tangent. And so you could think of cotangent as 1 over tangent of x. Now, more often, I don't often use this sort of reciprocal definition. I'm more likely to think of it in terms of sine and cosine. I find that more helpful. So I would, put a little star next to that one. This is sort of the common one we use. Now, we can also think about it on a coordinate plane, because remember, tangent, our tangent of an angle tells us the slope of that terminal ray, which would be our y value divided by our x value. So if cotangent is the reciprocal, it's actually going to be our x value over the y value. And that just sort of gives us a sort of general introduction. I would say make sure these ideas within, sort of these questions are written down somewhere in your notes. They're going to sort of come back, and we're going to be referring back to them as we sort of work through some more, like, what are we doing with these other trig functions? So let's talk. Let's think about these some more. And so we're going to be thinking about, where are cosecant, secant, and cotangent positive or negative? And because, as we're learning about trig functions, we think about, our sine, it's positive in quadrants 1 and 2. And so, okay, we have a terminal ray. It's swept out, some unknown number of radians, and it winds up in quadrant 2. So I always like to start, and I'm going to just draw us a little picture. Whenever I'm given something like that, it's just helpful to have, here's my quadrants. I'm going to, use blue for my angle. I got a random angle into quadrant 2. Doesn't really matter what the size is, and we're going to call that theta. Now, if I were finding sine of theta, the question is this positive or negative? And then how do we know? This is a little bit of review from some of our previous units. So remember, sine is giving us our vertical distance. So think about it like sine would be, our vertical distance here measured in radius lengths. And in this case, we're going above our horizontal axis. So sine is going to be a positive value. So sine is positive because sine of theta represents a vertical distance, or you can also think of it as your y coordinate, and which is positive in quadrant 2. All right, well, the next question is asking us to think a little further. So now we're looking at our cosine value. And remember, cosine is going to be sort of our horizontal distance to that vertical. Now, in this case, our horizontal distance is moving in the negative direction. So cosine of theta is negative because the horizontal So distance, or our x-coordinate, is negative in quadrant 2. All right, so we're still just looking at our normal trig functions. So we got sine is positive, cosine is negative, and of course now we're looking at tangent. Well, tangent's the slope of the line. And if I think about this terminal ray as a line, that line's going to have a negative slope. So tangent of theta is negative because the slope of the terminal ray is negative in quadrant 2. Some people might also argue, well, tangent of theta is equal to sine divided by cosine. And since our sine value is positive and our cosine value is negative, a positive number divided by a negative number would result in a negative number. So that would be another sort of approach for justifying why tangent is negative in this case. But here we're going to get to the real reason we're thinking about this. So we have our three sort of main trig functions. We know sine is positive, cosine is negative, tangent is negative. So what about the reciprocal functions? Where would they be positive or negative? And let's actually go back to some of those reciprocals we saw on numbers 1 and 2. What you should notice is that when the fractions when the cosine value was negative, our reciprocal was also negative. And when, our fractions were, when sine was positive, our reciprocal function was also positive. So when we're dealing with reciprocals, it's not impacting the positive or negative. These aren't opposites. They're just numbers that when I multiply them, they equal 1. And so it actually makes sense that a negative times a negative, I want a positive 1 out of those two fractions being multiplied. And so it would make sense that both of those values should stay negative. So in the case of this particular problem, that would mean, so sine is related to cosecant. So cosecant, it helps if I can spell it correctly, is positive because sine is positive. It's the reciprocal of sine, and we know sine is positive. Just as cosine, not cosine, just as secant of theta is negative because it's the reciprocal of cosine, and cosine is negative. And cotangent is also negative because it's the reciprocal of tangent, and tangent is negative. So they should share the same signs as their original functions. The reciprocal functions are the same. So part of this little exploration is so that, okay, what if we're given information like what we're given on number 6 here? We're told that tangent is positive, but secant is negative, and we want to sketch a sort of drawing of where that angle might wind up. Now, if I'm thinking about this, remember we've talked about tangent being positive when the slope is positive. So in this particular case, slopes are going to end up being positive in quadrants 1 and 4. I drew it in the right place and named it wrong. So I know tangent has to be positive in quadrant 1 or 3. But I'm also given that secant is negative. Well, we talked about secant is the reciprocal, and I like to make a note of this to myself. It's the same thing as 1 over cosine. So that means it's going to be negative when cosine is negative. Well, cosine is negative where our x-coordinates are negative, where our horizontal distance would be negative. So that's going to wind up in quadrants 2 and 3. And where do my two sort of areas overlap? Well, they overlap down here in quadrant 3. So we're going to go through, and if I drew in this angle, then my angle is going to wind up over here in quadrant 3. I'm going to erase my sort of extra notes because I don't need them anymore. Oops. Lost some of my coordinate plane. And then here would be where angle X is. And so we said this one had to be in quadrant 2 or 3. And so then, you know, the overlap was in 3. Thinking about similarly here, so we're told sine of X is positive. Sine is going to be our vertical distance. So we know that our vertical distance is positive in quadrant 1 and 2. So sort of our top part of the graph. Cotangent is the reciprocal of tangent. So that's going to be equal to 1 over tangent. And so it's negative. We're looking when it's negative. So negative is going to be when we have a sort of negative slope going on. Well, that's going to be in quadrants 2 and 4. And so where is the overlap? The overlap's occurring in quadrant 2. So I'm going to sketch in that angle to the best of my ability. Draw in my angle X. And ta-da! There are my two angles that give me some ideas based on that positive and negative.